Namaskar my dear friends. We have already seen LED selection process. So in this session what we will try to understand is how we can select various automotive chip LEDs. Okay. So as you can see there are various LEDs that are used in car interiors or blinkers or maybe side indicators or something like that, and they are very high brightness LEDs requirement or otherwise little bit dim LEDs are required, right? So we have to understand which are the manufacturers and how we can select a particular LEDs. So I'm going to take an example from ROM semiconductor because there are various manufacturers like Lighton is there, then Sun LED is there, we have King Bright, we have Worth Electronics. So we'll be taking ROM semiconductor, which is I feel can give you a better understanding. Okay. So as you can see from semiconductor we have automotive chip LEDs monocolor type. I will be taking example today, and it has a very good lineup of chip LEDs which include compact type, high power type, side emitting type and rear mount type, in addition to all the standard types as well. Okay, so even standard types also if you want to use you can use, otherwise in automotive industry also you can use. So the three figures I have shown you, like here it is flat type, here it is molded type, here it is little bit diffuse type. Okay, so as you can see there is a various range of LEDs that is shown here with different sizes and different LEDs type. Okay, so if you see we have categorized like low brightness, middle brightness, long life, we have a standard type, we have low current type, high brightness type. Understood? So each of the categories will be having different colors as well, whether you need violet or red or green or like a yellow or magenta, whichever color is needed, that can be selected from this particular table. Okay, so what I will do is I'll take you to the website directly and I'll show you this particular figure, and I'll also tell you how to read the data sheet. Okay, so data sheet of one of the LEDs we will take as example and we'll start finding out. Okay, so let me come to directly ROM semiconductor website, and as you can see we have home LEDs. If you go, then you go to chip LEDs monocolor, and we can go to automotive chip LEDs monocolor type. Okay, so as you can see this particular LED easy chart is given here. If you want you can select your options like which is the size of the LEDs that you want. 1.6 cross 0.8 will be approximately 0603 type. Okay, a little bit bigger size it will come at 0805 or 1206, something like that. Okay, coming back to the emission color, if you want to choose you can choose emission color like red, orange, yellow, yellowish or green or bluish or blue or white color, anything is fine. Okay, coming back to understand this particular understanding, like I told you already that this is low brightness. It can be used as reflector, and it can be used in car interior or exterior. That also is given in the data sheet. Okay, the series is mentioned like this, CSL 1101. Similar to that other LEDs will be there for different applications. Okay, got it? Got it. In parametric search also, if you want, in any website you take, like any manufacturers you take, they have the parametric search which tells you whether it is recommended for new design or something like that, and what is the packaging that you want. Okay, similar to that, what is the application that you are looking for, whether it is industrial equipments or automotive equipment. Okay, then which color you want it. Okay, similar to that other like parameters. Okay, that I have already explained you during the LED selection process, like what are the different parameters that we need to take into account while selecting a LED. Okay, good. So we have lot of like list of the LEDs products for your car application, and you can see the best part is they have told you like what is the package type and where it can be utilized. It is in car interior or something like that. So if you are a beginner in hardware industries, or like you are beginner of circuit design, then this is the best way to start with selecting an LEDs for your projects or for your design, so that you can become an expert in circuit design industries. Okay, let us take one of the example that we'll take. Example that I'm going to take is CSL 1101 WBAW. Okay, so this is going to be an yellow LED. Okay, and it is bit low brightness LED. We will take high brightness as well. So you have the data sheet, you have sample options, you have buy options and everything. It is there in every industries. That is very standard types. Okay, now coming back to the specification, so you can see that it is like a reflector type package, and like flat type it is, and then it is LED type is low brightness. We have package size as 1.6 cross 0.8 mm and thickness is 0.55 mm. Emitting color is white color. Luminous intensity is going to be around 155. So it is low brightness means 155. If you have high brightness, it will go up to around 1000 MCD or something like that. Okay, number of brightness rank is 4, and like chromaticity coordinate is this much. That is not of like much interest. We have forward voltage typical 2.9 volt. We have forward current which is going to be up to 20 milliamps, and chip structure is indium gallium nitride based. We have power dissipation up to 68 milliwatt, and we have operating temperature going up to 110 degrees centigrade. 100. Okay, so let's get into the data sheet. Basically this is having some features like source of light for display unit or something like that. So generally it is used in display units because of low brightness, right? So this is the data sheet that I'm going to explain you, like what are the different parameters that is there inside a data sheet of an LED, and this is going to be very important for any of the hardware design engineers or like electronics design engineers who wants to select any component before going to put it into the schematic. Okay, so as you can see, the uses of these are like it is given in the very first page itself. We have source of light for display units, and some of the absolute maximum rating is given here, like power dissipation is 68 milliwatts. So you have to make sure that the power dissipation is not exceeding this much. So how will you calculate this one is the voltage drop is there basically across the diode, which is going to be, let's say 3 volt or something, or 2.9 volt, multiplied by the current that is flowing IF. So let's say 20 milliamperes. Then the total power dissipation PD will be V into I, that is going to be 3 into 20, that is going to be 60 milliwatts. So this must be less than 68 milliwatt, otherwise it will fail. So generally IF current is used around 5 milliamperes or 4 milliamperes, that is more than enough. Okay. It can take up to forward like peak forward current as 100 milliampere. Reverse voltage it can withstand up to 5 volts. So you must have to understand that you are not supposed to give reverse voltage more than 5 volt. Okay, then we have temperature, operating range and all we have understood. We have to see forward voltage as well. So forward voltage, as you can see, the maximum voltage that is going to be 3.4 volt, right, and typical is 2.9 volt. So you must understand the LED circuit structure will be like this. Okay, let us say if you are going to supply some voltage V input, so this must be around 5 volt. It won't work with 3.3 volt because maximum voltage drop itself is 3.4 volt, right? So based on the current requirement, you can select your R1 value, and this is how the LED will be working. Another method of working this particular LED will be like this. Let us say I want to utilize my microcontroller as the sink. Okay, so in that case I will have to utilize like this will be going to my MCU pin, which will be having 5 volt tolerant. Okay, and this is my LED, and this is the source, right, V in. Okay. If you want, you can utilize this one itself as source, or otherwise sometimes microcontroller can work as a source. So if you want, you can have voltage input here, or otherwise microcontroller GPIO input here. Okay, so microcontroller can drive also and can sync also, both can happen. Understood? Similar to that, reverse current will be having a 10 microampere luminous intensity. As you can see, it is going up to typical 155 millicandela, and chromaticity coordinates is x coordinate is 2.282 and y coordinate is 0.249. Okay. Luminous specification or classification is something like this. Okay, so if you have like S1 symbol, S2 symbol, T1 symbol, T2 symbol, okay, then in that case S1 is from 90 to 110, S2 is 110 to 140. So like that, the categories are for the luminous intensity or the intensity of the light that you will be getting. Coming back to chromaticity diagram, so anyway, this is not of much utilization. Let's go to product weight and all is fine. Yeah, this is very important. We have product dimension. Okay, so this is generally used by the layout engineers, and you will also be required to understand before selecting the component. So the overall size is 1.6 mm cross 0.8 mm with 0.1 mm tolerance. Okay, and we have this cathode index. So cathode index is nothing but it looks something like this. Okay, this is my LED, so this is my cathode, this is my anode, and cathode index will be like little notch type. Okay, the thickness is like, or the height is 0.55 mm. If you see the like bottom side, then it has some curves or something like that. So this is how it will be looking like. This is the pad. So a cathode pad is like this, the small one. This one is cathode pad and this is your anode pad. Okay, so anode pad is bit wider. Okay, and this is the gap between the cathode and anode, which is 0.2 mm. And this is the symbol that I have shown. Generally many manufacturers give the symbol like this also with arrows mark, so that it gives you an LED emitter. Okay, this is the reels that we don't have to worry about. This is our not our scope. Coming back to next, packaging and all is fine. Let me give you an understanding of application method and mounting. I want to show it to you some of the curves that are very important. Okay, which need to be taken into account. Coming back to this. Okay, so if you come down here, we have relative luminous intensity versus atmospheric temperature. Okay, so as you can see, my temperature is starting from -40 degrees centigrade to 110 degrees centigrade, right? So as my temperature is increasing, my relative intensity is actually decreasing. Okay, so up to around 25 degrees centigrade or 20 degrees centigrade, we have relative intensity more than 1, that is 100%. Okay, and as you come like with more higher temperature, my relative intensity decreases and goes up to around 0.75%. Okay, 0.75, that is 75%. So it is still good. Like if it is like a more, sorry, it is 0.85%. So if it is more than 80%, then it is always good. Okay, so this is how you are going to decide your LED is having more than 85% of relative intensity, even if at temperature 110 degrees centigrade. Okay, with you can see the test diagram is for forward current of 5 milliamperes. Coming back to ratio of maximum tolerable peak current that it can take up. Okay, so let us say IF maximum tolerable peak current is going to be 5. Okay, and pulse duration is in microsecond. Okay, so if it is going to take up 5 milliamperes, then this is how the pulse duration will be looking like. So it can take up to more than how much 20 microsecond it can take with 5 milliampere pulse, 5 milliamperes of current, right? Coming back to relative intensity for versus forward current. So this is the forward current that is going to increase up to around 20 milliamperes. I told you, like this particular LED can take up to 20 milliamperes of continuous current, and you can see the relative intensity is going up to 3 times, that is 300%. Okay, so as you go on increasing the current through the diode or through the LED, the intensity or the brightness increases. Okay, so if you want to keep it around 100% of brightness or 100% of relative intensity, keep your current passing through the LEDs around 5 milliamperes. Okay, so this is more than sufficient to design your circuit, which is going to be 5 milliamperes. Coming back to forward current versus forward voltage, so as you can see, as my like forward current is increasing, my forward voltage requirement also increases. So it starts from, let's say, 2.7 volt or something like that, and going up to 3.4 volt maximum, which is going to be at 20 milliampere. This is in log scale. The current is in log scale. Okay, so 10, 20, 30, like up to 100 it is reaching. And at around 5 milliamperes, let's say this is 1 2 3 4 5, so this is my 5 milliamperes of current. So at 5 milliamperes of current, the forward voltage drop is close to like 2.9 volt. Okay, so this can be utilized for 3.3 volt application as well, with current up to around 5 milliamperes or 6 milliamperes. Got it? Now let us say if you want to use up to full scale, then you have to definitely go ahead with 5 volt like logic labels, then only it will be good. Very good. Understanding for the D ratings, like how my based on my ambient temperature, my maximum forward current decreases. Okay, so as you can see, up to around 85 degree centigrade or 84 degree centigrade, we have a complete 20 milliamperes of current capabilities. Okay, and as my temperature increases further, what is happening? My current capability is decreasing linearly, and it goes to 0 at 110 degrees centigrade. Okay, so make sure your LED is being used below 80 degrees centigrade or 85 degrees centigrade, so that you can use complete span of your like current ratings. Or if you want to use 5 milliamperes of current, then it can still work like around 100 degrees centigrade or 105 degrees centigrade very easily. Okay, coming back to thermal resistance. So thermal resistance value for 1 watt of dissipation, it is going to give you 240 degrees centigrade increase in temperature. So as you saw, 68 milliwatt was the capability. So 68 milliwatt is not going to increase 240 degrees centigrade. It will be very less. Okay, so if you want to multiply how much is the let's say you are dissipating 60 milliwatts of current, 60 milliwatts of power, then what will be the delta T that will be increased, or the temperature that will be increased in this is 240 degrees centigrade per watt multiplied by 60 milliwatts. Okay, and in that case you are going to get 144 and 0 and then milliwatts. So this 14.4 degrees centigrade, that is just 14 degrees centigrade increase will be there in your temperature. So let us say outside temperature is even 50 degrees centigrade plus 14 degrees centigrade is going to be 64 degrees centigrade. Okay, and generally environment temperature is around 25 degrees centigrade, so that is going to give you just 39 degrees centigrade temperature of the LEDs, which is more than sufficient to work in all the like conditions. There will be any D rating as at all. Okay, so this is very good thermal resistance values as well for this particular LED with the given power dissipation capability. So this is my power dissipation value, which was maximum. And even if the worst case we are going to take in our design is 60 milliwatts, generally it is not going to be 60 milliwatts. Why? Because 3 volt is the drop multiplied by 5 milliamperes, so this is going to be just 15 milliwatt, which will be even lesser power dissipation compared to the like 60 milliwatts. So hope you have a now very good understanding of how the power dissipation works and how my temperature is increasing based on the power dissipation across the LED. Junction to ambient temperature resistance is same way 340 degrees centigrade, and junction temperature is up to maximum, it can take up to 125 degrees centigrade. So if you want what is the temperature difference between junction to ambient, then also you can calculate the same way what is the temperature difference. That will be 340 times the total power dissipation that is there. So this was very important for your design purpose. Coming back to forward current and chromaticity diagram, so you can see as my x coordinate is increasing and y coordinate is increasing, you can see the current is there which is going to be lesser and lesser. Okay, so as you go below the chromaticity diagram, okay, your current forward current capacity is increasing, going up to 20 milliamperes. Okay, so I suggest you to keep the chromaticity diagram around middle, which is going to be around 10 milliamperes or something, which is going to be 0.285 or 287, and this is going to be 0.2 4 5 6 7 2.27. Okay, so 0.27 and 0.285 is your x side and 27 is for y side. So coming back to the viewing angle, so viewing angle generally it is given in the data sheet, like let's say it is going to talk about plus minus 45 degree or plus minus 60 degree or plus minus like 80 degree. So if it is plus minus 60 degree, then total viewing angle will be 120 degree. It will be total 90 degree. It will be total 160 degree, right? Like this it will be working, correct? So as you can see, my relative intensity is given in percentage. So let us say you are seeing at 50 degree, okay, angle, then the relative intensity will come at this, which is going to be around 60%, okay. So you have to put this curve like this and you will get the intensity, okay. Let us say you are going to see at 0 degree, then you are going to see complete like intensity that will be there, which will be like this thing. So the viewing angle I think you can take up to plus minus 40 degree, 40 degree left side and 40 degree right side. So this is the complete span that will be like good for your scanning angles. Similar to that, this is like this was XY scanning direction, which was XY, and this is X dash Y dash, which is kind of like imaging. So this is also almost same compared to this one, which is little bit lesser and bit higher intensity. Good. So all these things are there. Now coming back to some of the reliability data that also like provided by the manufacturer, which is going to be this is the product, this is the SMD type, and this is the product series, and they have given you some of the reliability data that how many numbers of pieces are sold, like test, and what is the solderability, what is the drop test, what is the vibration test, what is the thermal cycle, high temperature storage, load life, everything. What is the failure criteria, also they have given some of them. Let us say like luminous intensity, if it is condition is forward current is 5 milliamperes, then it is going to tell you 60% of its initial value like will be available. If forward voltage is like forward voltage, the charging rate of plus minus 10%, okay, changing rate of plus minus 10% forward voltage can change, okay. If reverse current is there, the maximum specification it can take up, there is no problem at all. Appearance, visual checkup, no major change in the appearance, like whatever is being told in the data sheet, all will be available. So these are the parameters that we have to always look into the reliability perspective, okay. So that's all. This was all about this particular data sheet. Similar to that, some other data sheets are also there, you can take up. We have, like, let's say automotive long life industry standard 1608 package blue chip, and it is having like a small size, and this is going to be bluish green for car interior application. Whether it is high brightness or low brightness, that also you can take up based on the data sheet that is given here. So this is the data sheet, okay, and same way all the specifications are there. So this is also low brightness dim LEDs, okay, for car interior application. Similar to that, if it is like you want to use some high brightness LEDs for indicator purpose or something like that, this is one of the like a series which is going to be yellow, green, or cheap LEDs. And you can see this is high brightness LEDs, a small LEDs with lenses, high brightness type, and AC 102 qualified, okay. And as you can see, I told you the very specific thing was power dissipation will be little bit higher, as well as my MCD rating will be 120 MCD, okay. So you can see here this is the data sheet for that particular understanding. So 4 5 data sheet I had opened it for you to understand, like what is the like understanding of this particular automotive LEDs, how to select them, and what are the different criterias for selecting the particular LEDs for our automotive or industrial applications. So if you do have any questions or any queries regarding the selection of automotive chip LEDs for different perspective, like whether it is side indicators or car interiors or like exteriors applications, you can reach out to us and we shall be able to give you the perfect match for your particular design. Alright guys, if you're liking our videos, or if you're liking the sessions, please like and subscribe our channel, and put down your queries or comments in the comment box, and we shall be come up with the best answers that is possible from our side. Thank you.